In this lecture, we will go over to polarization. So to understand what actually is polarization, let us go to this diagram here. Here we have two different configurations of the ions, the cation and anion. To the left of this dividing line, we have a configuration in which the atoms, the ions, that is cation and anion, are isolated from each other. That means the distance between the cation and anion is sufficiently large enough in order to prevent any kind of attractive interaction between the cation and anion. In this situation, in the isolated state, the electron density of the anion is symmetrically distributed around the nucleus because it does not have any kind of interaction with the cation. On the other hand, to the right of this dividing line, we have a configuration in which the distance between the cation and anion is sufficiently reduced in order to have some kind of attractive or repulsive interactions. Due to this attractive or repulsive interactions, we have what happens, the electron cloud of the anion, which was spherically symmetrical in the isolated state, becomes unsymmetrical due to the attractive force of this nucleus on the electron cloud of the anion and the repulsive interaction between the nucleus of the cation and anion. This distortion in the shape of the anion is what we call polarization, the process, the phenomenon of polarization. As far as the shape of the cation is concerned, they too get slightly distorted, but since that is negligibly small, we are not taking into account of the shape of the cation at this point of time. Now we have another important term, that is polarizing power and polarizability. Polarizing power is the power of cation to polarize an anion. On the other hand, polarizability is the tendency of the anion to get polarized by the cation. Now that we are done with understanding what is polarization, let us go to the text here and understand what are the things that are there in the text. We have the formula for calculating the percent ionic character. Now we should understand why we need to calculate the percent ionic character at the first place. So to answer this, whenever in inorganic chemistry we see a bond, then we cannot exactly say that the bond is 100% covalent or 100% ionic. In fact, every bond has covalent character and ionic every bond has ionic character and covalent character at the same time. So we have the formula here to calculate the percent ionic character in any covalent bond. We need to know the delta electronegativity, that is the electronegativity difference between the atoms that is bonded together. And here is a special case that when we have delta electronegativity as 2.1, then the bond would be 50% ionic and 50% covalent. Now we see the formula we can calculate the percent ionic character in any covalent bond. But what about calculating percent covalent character in any bond? Then the answer is that we cannot practically calculate the covalent character in ionic bond, but we can compare the percentage of covalent character between two bonds by using Fazan's rule. Now these points have been explained in the diagram here. Now let us focus on this text here. We have learned just now that we cannot exactly calculate the percent covalent character in any bond, but we can compare. So how we can compare? What basis should we use? So we should understand, we should go back to the basic definition of covalent and ionic bond. We have learned that in a covalent bond, the bond is formed by the sharing of electrons. On the other hand, the ionic bond is formed by the complete transfer of electrons. So whenever the sharing tendency would increase, then we would say that the compound will have a greater covalent character, and when the sharing tendency would decrease, then we will say that the compound has a less covalent character. So when would sharing tendency increase? So sharing tendency would increase whenever, you see, we can see here we have cation here and we have anion here. Suppose this cation is able to polarize the anion by a larger degree, then what happens? The electron density between the cation and anion would increase drastically, and the sharing tendency of this anion would increase. So in such a scenario, the covalent bond between these two compounds, these two ions, would be greater compared to the ionic character. So this is what basically is Fazan's rule. Now we have some parameters on which the polarization is dependent. Here are those parameters. We should remember whether it is directly or inversely related. So polarization is proportional to the polarizing power of the cation and polarizability of the anion. We have learned what is polarizing power and polarizability, and it is also proportional to the charge on cation or the charge on anion. And the important thing here is that it is inversely proportional to the size of cation and directly proportional to the size on anion. Okay, size of anion. So we are done with all these basic terms here and basic definitions and how we can calculate the percent ionic character, how we can compare the percent covalent character using Fajan's tool, and we have also seen the parameters on which the polarization is dependent. In next lecture, we will go on to the polarizing power of S block, P block and D block cations. We will basically do a comparison test whether the polarizing power of S block cations would be greater, or P block or D block cations, or even in between two S block or P block or D block cations, which element would have a greater, which ion basically would have a greater polarizing power. We will all deal with all these things in the next lecture.